Hi, welcome to Bloom. Today we are going to discuss the fourth lesson in our A-level syllabus, digital circuits. Here in this video we are going to discuss about Boolean algebra. So let's see what are the fundamentals of digital circuits. The first part will be on Boolean algebra. So what is Boolean algebra? It is also referred to as binary algebra or logical algebra. This is the foundation of digital circuit design. It is named after George Boole, who defined an algebra to manipulate it with true and false values. True is denoted as 1 and false denoted as 0, or maybe true is considered on and false is considered as off. Only two binary values. Boolean algebra has three basic operations: conjunction, disjunction, and negation. Conjunction is the intercepts of A and B, and it is denoted using this gate AND. Disjunction is the addition of both, which is denoted by OR gate. And negation is not B means this area, not. So what is a Boolean expression? As you can see, A and B are Boolean variables, and the operation done on A and B is a AND. This is the logical operator, and A and B equals true. This is a Boolean expression. The same can be represented using the full stop. Instead of AND, we can use full stop. When we are working with Boolean algebra, we have to learn about truth tables. We have to use truth tables. What is truth tables? It shows different value combinations for Boolean variables. In this example, for an operator A and B, there can be four different combinations. A can be either 0 1 and B can also be either 0 1. Then there are four combinations, and we can show the result in this format. For O operator, then again A can be either 0 1, B can be either 0 1. For A or B, there are four combinations. When A is 0, B is 0, A or is 0. In all other three occasions, when either one or both are 1, A or B is equal to 1. And for not operator, if A is 0, then A not is 1. If A is 1, A not is 0. So we can represent all the possible occasions using truth tables. The perfect induction is the use of truth table to describe the validity of a Boolean expression for all possible value combinations of Boolean. Now let's see how to prove a Boolean expression using truth tables. Here we have got this equation: x and x of y equals x. Now let's see how to prove it. Both x and y can have 0 or 1 as their values. Then x or y 0 0 1 1 0 1 1 0 1 1 1 1. When there is a O, the values are getting added. Then we have to multiply this with x. So this is AND 0 0 0 0 1 0 1 1 1 1 1 1. So when there is AND, if either value is 0, then the result is 0. But if both are 1, then the multiplied result is 1. So here we have got 0 0 0, 2 zeros and 2 ones. X also has the same combination, so left hand side result is this, right hand side result is this, both are equal, so this is proven. When we are learning Boolean expressions, we need to know the axioms of Boolean algebra to solve problems. There are several axioms that you should be aware of. The law of identity, it is like A equals A, negotiation of A equals negotiation of A. In the cumulative law, it says whether the order of appearance A and B or B and A both are equal. The same applies for OR gate. A or B or B or A both are same. Then the associative law is about the way you have put the brackets. You can put either brackets here, then or here, but still it's the same. The result is same. That's same for the OR gate also. The double negative law. If there's two double negatives, it's again considered like no negative. That's double negative A means equals A. Then the complementary law. So here, if A is multiplied, that's end operation. A and negative A equals 0. Because if we can see if A is 0, then negative A is 1, then 0 into 1, 0. If A is 1 and A negative is 0, then 1 into 0, that's again 0. Here, if it's A, if A is 1, A negative is 0, then the addition, that is the OR gate, is 1. Then the idempotent law. Here, if we multiply or add the same Boolean variable, it's the same. A and A is equal to A or A is equal to A. Then the law of union. So anything added to 1, it's 1. Anything 0 is added to any Boolean variable, it's like there's no 0, it's same the Boolean variable. In the law of intersection, A and 1 equals A, but if A and 0 is 0. Then the De Morgan's theorem, it is very important because we need this when we are simplifying Boolean expressions. AB negative equals A negative plus B negative, and the opposite, the second law is A and B totals negative equals A negative B negative. Then the distributive law is like A and B plus C. Here we can multiply AB, here AC. And here A plus BC equals A plus B into A plus C, because here when we multiply A into A is equal to A, then A into C, B A and B C. We can simplify it further using these laws, and the result is A plus BC. Now let's see how to use Venn diagrams to prove Boolean axioms. Here we are going to prove De Morgan's theorem. AB negative equals A negative plus B negative. So AB means A and B. It's like if we draw A, B, the intercept. part is A and B. The negative of A and B is total this area excluding this. And let's see what is negative A. Negative A means A or total area except A. Then negative B. Negative B means total area without this area. Then A, negative A and negative B is the total area colored excluding the area that is not colored in both diagrams. So here, so when we add, we can see this area is not colored, other area is colored, so we get the same result here. A, B negative, this area, and the total area, other area is colored. A negative, B and plus B negative, again we get the same result. So we can prove this law using Venn diagrams. Now let's see how to use Boolean algebra to simplify Boolean expressions. Here we have got a clause sum of product expression. Now let's simplify it. When we are going to simplify, we can see there are common Boolean variables in both these clauses. Negative A, B, negative A, B. This is common to both items, and then here AC is common to both of these. So using the distributive law, we can take them outside and we get this clause. And here again we can take AC outside the brackets and we get this. Then here we see negative C plus C. So using the complementary law, we can say this clause is equal to 1, and here again it's 1. Then we get negative AB plus AC. So when we have 1, we can use the law of intersection and we can say it's like AB plus AC. So we have simplified this long expression into a simpler value. So here we have come to the end of our today's lesson. Thank you for watching the video. Stay connected to watch our next lesson on K-maps.